Lesson 5-4, complex numbers. There's going to be two parts to this lesson. So today we're going to focus on square roots and performing operations with square roots and imaginary numbers. So here's a couple properties that you need to know. First of all, if you have a square root of a product like a times b, you can always split it into two square roots, the square root of a times the square root of b. This will come in handy later. And if you have the quotient under a square root sign, you can always split it up as the square root of the top number over the square root of the bottom number. Okay, so here's the first one. We want to simplify these, and that does not mean type them in on your calculator and write down the decimal approximation. Now we know that the square root of 50 is not a whole number. Okay, these are irrational numbers, but we can simplify these square roots if a perfect square divides into 50. Now, the perfect squares are numbers that have even or equal factors, like 36 is a perfect square because 6 times 6 is 36. Or 25 is a perfect square because 5 times 5 is 25. Okay, so I want to try to find factors of 50 in this first example that, where 1 is a perfect square. So, my pen maybe will work. There we go. Okay, so I'm going to split 50 into two factors. And again, I want one of them to be a perfect square. So if I think about, a perfect square that divides into 50, right away 25 jumps to mind. So I know that 50 is 2 times 25. So I can split up the square root into the square root of 2 times the square root of 25. Now the square root of 25 does simplify. The square root of 25 is just 5, and then we can write our answer in simplest form with the whole number first, 5 times the square root of 2. So simplifying square roots, we're looking for a number that can come out of the square root, in other words, simplify, and then, if it's not a perfect square, like 50 is not a perfect square, there's usually something left inside the square root sign. So in this case, 50 is 25 times 2, and the square root of 25 is 5, so I've got 5 times the square root of 2. All right, let's try letter B. So this one is the square root of 11 over 49. Okay, so the square root of 11 doesn't really simplify, nor does it have any factors that work here, so I'll just leave it as the square root of 11. However, the square root of 49 we can simplify. The square root of 49 is 7. So I've got the square root of 11 over 7. Now it's simplified. And we use property number 2 there, where you just take each number and set them up as separate square roots. Okay, then finally in letter C, I've got the square root of 45. I want to think about the factors of 45. So what numbers go into 45? Well, 1 and 45 and 5 times 9. 9 happens to be a perfect square. So I'm going to split up the square root of 45 into the square root of 9 times the square root of 5. You can do this using property number 1 on the last slide. Now we know that the square root of 9 is just 3, and so you can reduce this or simplify it by writing it as 3 times the square root of 5. Okay, the square root of 45 is the same as 3 times the square root of 5. Now imaginary numbers. We usually use the letter I for imaginary numbers, and this happens when you take the square root of a negative number. So I, just by itself, is defined as the square root of -1. Or if I write another example, the square root of -36, you would put 6i. So anytime you're taking the square root of a negative number, basically you can think of the same square root here, but if it's negative, you got to add an I behind it. Now, because of this definition here, if I square both sides, we know that I squared is equal to -1. By definition, I squared is -1, and I is the square root of -1. Okay, so let's use that in our next example. We're going to simplify these square roots. You'll notice that in each one now I have a negative sign under the square root sign, and so an I is going to be a part of my answer. Okay, so 18. Let's think of factors of 18. 3 times 6 or 2 times 9. Now I want one of them to be a perfect square, and so I need to use 2 times 9. Those are the square roots here. So 18, -18 is -9 times positive 2. Now, I put the negative sign with the perfect square because I'm going to want to simplify this, and I can simplify it into 3i. The square root of 2 I can't really simplify, so that will stay underneath the square root sign. And so my answer is 3i, because that's the square root of negative 9, times the square root of 2. Negative 18 is negative 9 times 2. Simplify the square root of negative 9 into 3i, and you're done. Let's look at letter B. I've got the square root of negative 27. So negative 27, that's negative 9 times 3. That's how I'm going to want to split it up. So the square root of negative 9 times the square root of 3 is the same thing as the square root of negative 27. I know that the square root of negative 9 is 3i again. And so my answer in simplest form here would be 3i times the square root of 3. Okay, last one. I've got negative 125. So again, you want to find a perfect square that divides into this. And right away, 25 is jumping out at me. Negative 125. The two factors that I would use here are negative 25 and 5. Now, we also have a variable in this example, x to the 5th. I'm going to show you how to split that up. So let's start out with negative 125, and I'm going to split that up into the two factors, negative 25 times 5. And I'm putting these under the square root bar, but I'm not really saying it. But we're talking about square roots here. So the square root of negative 25 times the square root of 5 is the negative 125. Now, how do I split up x to the 5th? Well, in order to take the square root here, a perfect square root, I need an even power. So I'm simply going to split x to the 5th into the square root of x to the 4th times the square root of x. X to the 5th is x to the 4th times x to the 1st. Now, what can I simplify here? Well, the square root of negative 25 is 5i. The square root of 5 I can't really simplify. The square root of x to the 4th is x squared. You split it up. And what I'm left with under my radical sign, under the square root sign, is 5x. Okay, so my final answer here, this thing written in simplest form, doesn't really look any simpler, but simplified, we've got 5i x squared, and that's the order you should write it in, the number, then the I, then the variable, times the square root of 5x. This we could not simplify, you just rewrite it then or leave it underneath the square root sign. Okay, so if you show your work and you break this up into pieces, simplify what you can, and then whatever's left underneath the symbol, rewrite it together. These aren't too difficult, they aren't too bad. You can solve them. Okay, a couple more simplifying with i's here. This time we're multiplying, and what I want you to remember here is the second definition that we had for I. I squared equals negative 1. That's the idea that we're going to use here. So if I'm taking negative 2i times 7i, we get negative 14i squared. But now we know that I squared is defined as negative 1. And so I can make a substitution. Negative 14 times I squared is the same as negative 14 times negative 1. And your answer is 14. There you go. No I in your answer because we took out I squared and substituted in negative 1. Let's solve letter B. I've got I to the 45th power. Now I squared equals negative 1, yes, so I want to make this power even. So I'm going to split it up into I to the 44th times I. Now, 44, I'm going to rewrite this so that I'm using a base of 2. Let me show you how it works. I want to use I squared because I know that I squared is negative 1. So I'm going to rewrite this first part. I to the 44th power is the same as I squared to the 22nd power, because the rule is when you have a power to another power, you multiply them. 2 times 22 is 44, and so I'm just rewriting this in an equivalent way, but you know, it looks a little different. I want I squared somewhere in here so I can simplify it. So I've got I squared to the 22nd power times I. Well, what does that give me? Well, I squared is really negative 1, so we're going to make that substitution. Negative 1 to the 22nd times I. Now, anytime you take a negative number to an even power, -1, if I multiply it by itself 22 times, I'm going to end up with +1, and then I still have my times I, and so I to the 45th turns out just to be the same as I to the 1st. Crazy, huh? Okay, so the whole goal here is to make I squareds and then substitute in -1, change it into -1, and simplify your answer. All right, last one here. I've got the square root of -10 times the square root of -15. Now, these are a little tricky because even though you might just say I can just multiply these and get, the square root of +150. It kind of works that way, but it kind of doesn't. So let me show you. You want to split these up into the square root of -1 times the square root of 10, and then times the square root of -1 times the square root of 15. Okay, that's your starting point. That's what you got to do first. Now, we know that the square root of -1s, these are really just I, so you can simplify those. And now what I'm really multiplying is I times the square root of 10 times I times the square root of 15. Okay, let's go from there and simplify this. So we know that I times I is I squared. And I know that the square root of 10 times the square root of 15 is the square root of 150. Now, can I do anything with that? Can I go from there? Well, I certainly can. So the square root of 150, 25 goes into it. Let's see, it'd be 25 times 6, right? So I can simplify this radical, this square root. So I would leave I squared out in front for now. And I'm going to split up 150 into the square root of 25 times the square root of 6. Now I know that the square root of 25 simplifies into 5. I also know that I squared is equal to -1. So I'm multiplying these three things now. -1 times 5 times the square root of 6. So my answer is -5 times the square root of 6. Okay, so it doesn't really work with these negative square roots just because they are imaginary numbers. It doesn't work to just multiply these and get +150. You have to bring an I out in front by factoring out that -1. So we simplified that first. When you get I times I, or I squared is -1, so it actually makes our answer negative here, even though I still had to simplify the square root of 150. Okay, last example, we are going to solve equations by isolating the x squared, taking the square root of both sides, and getting our answers. Okay, so first step here, I want to get x squared by itself, so I'm going to subtract 48 on each side. 3x squared equals 0 minus 48 is -48. Now I want to get x squared by itself, so I'll divide by 3 on both sides. X squared equals -16. Now we're going to take the square root of both sides. The square root of x squared is just x, so that's good. But over here, the square root of -16, it's the square root of a negative, so I know I is part of my answer. The square root of 16 is 4, so this has got to be 4i. Now, anytime you're taking the square root, you're going to put a plus or minus in front of it, so x equals plus or minus 4i. That's your solution. Now, the thing is with graphing these, if you were to graph this, you would end up with a parabola that doesn't cross the x-axis. And so, originally we would say there's no solution. Well, the real answer is there's no real solution, but there is an imaginary solution here. There's no real solution, but we do have imaginary solutions, and you can find them using this method. Okay, one more example to show you. If 4x squared plus 100 equals 0, what are the x values? Well, I'm guessing again that there's no real solutions here, but we can find some imaginary solutions. So let's start by isolating x squared. I'm going to subtract 100 on each side. 4x squared equals -100. Divide both sides by 4. x squared equals negative 25. So we are going to take the square root of a negative number here. Our solutions are imaginary. That means they don't show up on the graph, but they do exist. So the square root of negative 25 is 5 plus or minus 5i. 5 times 5 is 25, and we know that the square root of a negative needs an I in the answer. Okay, so a lot of stuff that we covered in this video, a lot of stuff that we're going to cover in class, and I'd like you to try the next 3 problems on your own.